Здравствуйте, спасибо за внимание. На время презентации я перейду.
Good afternoon. Thank you for your attention. I will make my presentation in English, but you can ask your questions in Russian. I understand Russian.
So we are going to talk about segment routing. Behind any brilliant technical idea has to be business case. So why are we doing it? What's going on in the industry? What's going on in standardization? What's been tested? What's really working? Modeling, data models. Why is it important to provide capabilities, to provide functionality every service provider has been looking for the last 15 years? Some use cases, how it's working with an open source project called Open Daylight, which is the SDN controller driven by Linux Foundation, and some use cases of it. So very few marketing slides. If you look at Infonetics review of 70% of CapEx spent, we see that three most important properties of SDN and expectations from SDN are time to market, time to revenue. So being able to quickly deploy services, real-time reoptimization, better utilization of your assets, of your network, and simplification. Simplification is really automation. If you drill down to protocol layer, layer 3 IP MPLS is definitely the most interesting one. This is the one which is deployed pretty much in every network today. This is the one which brings bread on the table. So talking about SDN, you might hear a lot of different stuff, right? SDN is really about separating of policy of your business logic from reachability in your network. And this is the assumption how proper working networking should work. A lot of people talk about full centralized model, everything getting centralized, we are just provisioning FIPS. There is no silver bullet when you start centralizing things. You lose agility, your system becomes rigid. It's proven mathematically, and this is the way we've been trying for the last 30 years to go centralized, decentralized, centralized again. So Scott Shenker, professor at Berkeley, colleague, worked a lot together. I was really happy to see him a few months ago. So he went out and really talked about what SDN really is. So he is one of the inventors of OpenFlow, co-founder of Nicira Network sold to VMware, and is seen as father of SDN. So he admitted what they thought about SDN initially. It was really academical way of thinking. All chipsets are homogeneous. There is no difference between edge and core. You can control all networking in one single program. Pretty much all those assumptions are not true when you start looking into the real world. So we spent a lot of time talking about network complexity. It's one of my favorite topics, and hopefully I contributed to this sphere. So he's going to talk more about what SDN really is, SDN v2, as he calls it. And the assumption really, you need to be able to integrate it with today networking. You need to clearly see the difference between edge and core, and complexity really belongs to the edge, either software or hardware. Core doesn't have to be complex. All it does, it moves packets from right to left. So Facebook and Microsoft have chosen routing in their data centers. I'm happy to tell you that most of this architecture has been driven by Petr Lopukhov, born here in Kazan, networking engineer at Microsoft and now at Google. So we worked a lot on this work. I'm shepherding this work in ATF. After testing pretty much any protocol in the world, we figure out that by having reachability distributed and centralized view and ability to override decision on a networking element, it gives you ability to scale independently of number of nodes on one side. On another side, it gives you ability to glue your business logic or your operational state to distribution of state. So why routing again? In 1999, Eric Brouwer has proven that you can choose only 2 out of 3. You could be either consistent and available and partitionable, or consistent and partitionable. If you look at routing after protocol is eventually consistent, so flooding is done, they're always available and always partitionable. So protocols came to the stage where they're extremely reliable, and it would be odd not to use this. So you hear a lot of messaging from vendor of your choice. Really, if you see someone coming to you saying, you must use this particular protocol, otherwise you are not SDN, or you are not this, or you are not that, they're trying to sell you something. Be pragmatic, be open to new ideas, use what you feel comfortable with, what your operational department is comfortable with. So I believe the golden middle is somewhere in between, where you logically centralized what must be centralized, however, you still physically distribute. So what's going on with segment routing in industry? From IETF perspective, we are pretty much done. All standardization work is done. All extensions to IGPs, extensions to BGP, extensions to PSEP, topology-independent model, they're pretty much done. Most documents are working group documents. We are going towards RFCs. Beginning of the year, February, so every February we go to Berlin to NTC Lab and we test for 2 weeks with every vendor. So as you could see, this year we've tested segment routing. 2 testing vendor, XCN Spirent and Cisco, Alcatel, and Ericsson. We've tested for 2 weeks. We've proven segment routing is working, both control plane and data planes. We can also do services on top. So services on top run where L3VP and 6VP for IPv6. Why is it important to you? When you are going to deploy segment routing, and I hope you would, you know in advance you are going to put any of these vendors in your network and they're going to work. There are a lot of talks about open source versus open standards. You might hear someone talking, open standards are going down, they're too slow, open source is going to take over. I think we need both. You need a combination. In IETF, we know how protocols work, how a package should be encoded on the wire. Open source on the other side brings agility and faster development, really. So by bringing together open source and open standard, we give you interoperability and agility. So a few words about NetConf Young and why. So NetConf Young has been around for quite some time. However, what happened about 2 years ago, especially after TLF been acquired by Cisco, suddenly every big tier one started to talk, guys, we are really sick about difference in your CLIs, in your behaviors. Why do I need to know how to configure BGP and OSXR, Junos, Timos, you name it, right? So NetConf has been developed as transport protocol to use for YANG. YANG is a data model language to model networking model. So about the same time, a group of people came together, and this group which is representing most of the money spent on the market today. Every US tier one is there, British Telecom is one, France Telecom. What they're doing, they're bringing declarative model-driven configuration. What it really means, you want a BGP configuration. You shouldn't really care about whether you configure Junos or Cisco or anything else. It's an abstracted model where vendor takes care of configuration. You want to configure a service, L3VPN, L2VPN, any service you run. Again, it's up to business logic of your OSS BSS layer to provide configuration parameters. It's up to model to instantiate it. Very important point, it's completely vendor neutral. Actually, there are no vendors on the board. So if there's a model, they ensure vendor implements it. Otherwise, they're just not going to buy their equipment. It's going to work exactly in a way you envision it. You just define type of service you want, and it's up to vendor to provide way to configure it. Very important point, it also includes telemetry, meaning you instantiate a service, you get immediately all the states, counters, anything which can actually prove your service is working. And it's open for operators. Models are available on GitHub. Drafts are available in IETF. Participate. Every operator is welcome. So this is OpenDaylight controller as of Lithium. You could see there's a huge amount of different southbound plugins. When I talk southbound, I mean from controller to the network element. And this is really what from my perspective, SDN it's a freedom from your side to choose a protocol which will instantiate networking for you. It doesn't have to be OpenFlow. It doesn't have to be BGP or anything else. It should be something if you're familiar with, something which your operational department can live with. So going back to programmable IP/MPLS. In order to be able to build a pass-through network, you need to know the topology. In order to do so, we introduced extensions to BGP called BGP link state, which expose network topology and artifacts of the networks. In this case, we are using jitter and delay, however, there are more. In order to expose attributes of segment routing, there are also segment routing extensions to BGP-LS, which expose segments or labels assigned to particular prefixes. Since topology is exposed, now we can take requirements from an application in terms of constraints and compute the path. So PC, path computation element, will take the topology, will take the constraints, and compute the path. Very important point, as you could see, we are not trying to use a particular protocol to instantiate networking. We push it down as a model. So any southbound plugin aware of this model can take it and configure it. Could be PCEP, could be CLI, could be really anything which supports this model. It results in true multi-layer model when you put everything together. So what I show here is a optical plus IP/MPLS plus LTVPN model. It's a real example from OpenDaylight. And just to show you variety of where we can learn the topology and provision it. So we learn optical topology through inventory. We just talked to an NMS. We learn IP/MPLS through BGP-LS. And we learn layer 3 VPN configuration, which is really policy. So it's top-driven from business layer. So what you get is full correlation. If optical node goes down, you know immediately which router or which service is going to be affected. You can provide different scheme of protection. For example, if traffic is best effort, probably IPFR is good enough. If it's a banking, probably you would need dedicated Lambda. So give you ability to innovate in terms of business services and how you sell this. Some use cases. So topology with 6 routers. BGP-LS northbound to expose the topology, PCEP southbound to configure paths. So as you could see, there are 2 paths available. And what we know about network, we know how nodes are interconnected. We know unidirectional bandwidth on every link. We know unidirectional delay. So when we receive a request from an application, in this case, is to provide a link which is at least 10 gig and with latency not more than 10 milliseconds. When we run first round of computation, we see that link BD has delay of 15 milliseconds, hence we prune it. We prune link or pass through the network which has this link in it. The only path available now, ACF. We publish the model. PCEP, which subscribed to this model before, will go down to ingress router and configure LSP. Whole thing takes 20 seconds. If you think how long it takes your organization to get a request from another organization, go talk to optical guys, go talk to service guys, configure the service, make sure it works, probably weeks. So now you can configure a service or actually have it fully automated within seconds. Another case, a request for 15 gig. As you could see, both links between router AB and AC are 10 gig. So if you take a view per link, you cannot assign 15 gig. However, hence, all the topology is exposed and you understand total capacity. You know that if you add both links from router A, you get 20 gig. So in this case, and segment routing helps us here since we have defined a so-called bundle label, meaning when router assigns this label, what it's going to do is going to load balance between every member of this group. So when we do look up here, we figure out if we assign both links, actually we can provide 15 gig. We will download a label which is bundle label and establish 2 different paths through the network. So this is to show a case where we can better utilize our network. And this was the primary use case for Google. So they went from 45% utilization to 95%, doing exactly that. Real-time reoptimization. There are more and more information coming from routers and any networking device. We are going from dump SNMP traps to real-time streaming. So we are notifying memory usage, any type of statistics leaving the router. So in this case, I'm really showing link gets overloaded. Right? Very simple. You hit a threshold, you notify. However, what it's going to do is going to trigger re-optimization. Since PC is stateful, it knows all the resources allocated in the network. It knows what's going on in the network. It could look on the network as a whole and recompute a new path. In this case, it sees that a BDF, the top path, has enough resources. It will download new path, establish it, and shut down all one. So you actually fixed your network before it got broken. And you can think about really any kind of analytics which can trigger optimization in your network. If you look at interaction of OpenFlow networks with IP or IP/MPLS networking, it's pretty much none today. You would provision OpenFlow action to forward traffic out of particular port. However, there's no notion of end-to-end path. There is no end-to-end O&M. If you assign OpenFlow logic with segment router semantics, you can do it. What you're going to do here is to assign a label to every OpenFlow switch, a label to every port on OpenFlow switch. So de facto, you are mimicking segment routing semantics on normal router. You use BGP-LS to expose this information back to IP/MPLS networking. So when you receive a request, and in this case, request is to establish a path from OpenFlow switch to the router, you know, in order to reach router 3, you need to push label 13. From OpenFlow perspective, it's nature action supported from OpenFlow 1.3, push label. So you're going to program every OpenFlow device to push label 13. When you hit first router in IP/MPLS domain, you know in advance where to go because label 13 represents router 3. So here you've got admission control, you've got end-to-end LSP, you've got end-to-end O&M. In optical case, when you provision a new optical path in your network and you expose it to your IP/MPLS layer, it's not the fact you are going actually to use it. Most networks today utilize UCMP, utilize link aggregation groups, or some other bundling topologies. So what it really means that hashing across the members of the bundle is local decision, so your new link might not be used at all. That's actually why we invented MPLS-TP, right? And that's why first thing we did, we disabled ECMP and LUKS. With segment routing, you can identify every constituent of the bundle, even if you're still using LUKS or ECMP. So you could keep greatness of dynamic IP/MPLS networking while it gives you ability to pinpoint pass through the network exactly the way you want. So it's coherent provisioning across both optical and IP/MPLS layers. It's a use case we worked with AT&T. So what they asked for, they've got data centers all across US. Their today networks is obviously Cisco Juniper. And they asked for being able to program paths through this network from data center perspective. So what we did with them, we enhanced OpenStack to signal not only connectivity requests, but also what kind of connectivity, bandwidth delay. In this case, we use SDN controller to provision edge data center switch. However, we can still use our core devices as they are. Since they're on segment routing, they expose their capabilities to the controller. There's nothing we need to do there. We just need to upgrade software. So to finalize, segment routing with SDN gives us simplification, faster time to market. OpEx reduction in terms of reduction of number of protocols. It provides, very importantly, I didn't talk about this, 100% coverage with APFRR cases. We call it topology-independent LFA. It gives the ability to fully integrate packet and Opta. So all the information is available on IETF. Working group Spring is in charge of segment routing. All relevant extensions are done by relevant group, so BGP in BGP, PSAP in PSAP working group. And may have any questions, just shoot me an email. Questions?
Yes, it's working. Evgeny Zobnitsov, Factor Group. I'm just interested in questions. First of all, I'm glad to see that vendors coming to this open area, especially with the open config approach, with to have the standardized APIs and also configuration ways and also some kind of open delight and open stack approaches. But What do you think about, from the vendor perspective of you especially, do you have enough space to compete in this kind of future when all interfaces will be the same?
So while interfaces are the same, vendors are not. Hardware has very different capabilities per vendor. And I think a lot of this is becoming commodity, right? Broadcom is coming. We see commoditization of whole space. The real value is in the software, in OSS, BSS, and business logic. So I think we are going to compete really on business logic. We know BGP works. We know OSPF works. So there's very difficult to compete. There's nothing to compete on, really. Business logic is a very different matter.
From my point, I'm for support this approach for 100%, but I'm just trying to understand what is the vendor point of view. Thank you.
So we would like to still be able to sell into the space, obviously. And then, from my personal perspective, I spent most of my life being service provider, not a vendor. So I would really like to see networking become a better place, and this is what it is. I mean, we became really masters of complexity. It doesn't need to be this way.
Дим Бурков. Джефф, я воспользуюсь говорить по-русски, чтобы не переключаться. Ну, так, у меня есть вопросы.
Jack, I will be speaking Russian, and this is a question from naive person from Diletant. End-to-end, it's all about one operator. So the go through end-to-end, it's just a dream, and it hasn't been solved yet. It's what's your take on this in future? And the question about the operator-to-operator interaction, because the more we work with content, and we're clear about that, and this is a problem, I will not go into history deep, because it's disgusting. But the second question is with the BGP, will we do anything ever with it? Otherwise, we can ask Yasha Richter to come here, who can get him and some other people. But as long as I remember, we have been trying to gather people to reconsider certain issues, because up on of this we have the behemoth, which is BGP. And the first question again is interoperability and what to do with the BGP. Interoperability from the architecture, segment routing, and we have the concept of mapping server, and the BGP is using these technologies together, gives us opportunity to connect domains and use different SOGM with the segment routing.
Such as seamless MPLS, where you use hierarchical MPLS to provide hierarchy over different metro domains. Segment routing with BGP LS could be brought on top to interconnect with different domains. So, I mean, technically it's visible. Inter-domain routing is usually administrative issue, not technical issue.
Почему я задал вопрос, собственно говоря, исходя?
I ask you this question, so coming from that, is that possible from the personal viewpoint, theoretically, that the appearance of certain public resource which will allow to automatically to establish that connections. So it might happen that in RIPE, we are the register which is being used for the routing tables. How it should be done, or should it be done just bilaterally, or then just private connection? No.
We've pretty much solved this kind of architecture with hierarchical PCs. So we know what to expose to higher level PC, how to exchange information at peering layer. I think with SDN we are going exactly this direction, where we'll define peering relationship, hierarchical relationship, and information which has to be exposed. So at the end, it should make life easier because you've got your well-defined enforcement points, which could be governed by RIPE. And I think bandwidth brokering, which is new business, already exists in the US, it requires really these capabilities because now you're going across different providers, trying to choose one which meets your requirements with regards to cost per bit, time a day, some other constraints.
Не, я просто пытаюсь свести к практике, на самом деле, потому что либо
Just trying to ask a practical question whether it will be based on the registers or these are the additional functions for exchange services. BGP.
So it's an old protocol. We all know all the issues. Highly abused. If you look at BGP-LS, it's nothing else than huge abuse of BGP. We use BGP as a transport. On another side, if you look at least at vendor's implementation, BGP is extremely stable. It really works. So being pragmatic person, I mean, I'm using BGP because it's there, because infrastructure is there. Deploy BGP-LS will only require to deploy additional address assembly on router reflector, and I'm pretty much done. I think what we are going to see in pretty much every, at least in vendor spaces, we will see complete separation of BGP being transport, such as BGP-LS, from BGP being protocol used for distribution of reachability. While the second is critical, you lose reachability, your network is down. Second, okay, so you don't have any updates for 5 minutes, who cares? So this is happening kind of, Cisco is doing it in XR, we are doing it in Ericsson. So you will see really multi-process BGP in a way. Problem in one address family is not going to affect one. If you look at IDR, all the work done on BGP, error work, we are already capable of decoupling problems within one update just by dropping it rather than restarting BGP session, which is a huge thing, really. So I think BGP is going to be there. Because it's there, it works. Don't fix what's ain't broken, right? So long term, there might be better protocol. I2RS is coming. NetConf is an amazingly rich protocol when you need to express something. But for time being, probably 3 to 7 years, I don't see any reason for BGP to disappear, both inter-domain as well as SDN use case. Надо дожить.
Он включен. Спасибо за презентацию. Меня зовут Сергей Мисаэтов. У меня такой вопрос. Я посмотрел.
My question is, I think you know vendors very well and with the hardware which can be used for the implementation of the SDN with all functions which we are talking about. What's the minimum threshold price-wise for the hardware which can be used? Okay, let's begin from the Broadcom, from the AGX. So on the cheapest segment, NGX is about
label, one VPN label, so 5 labels. If we look at DNX product line, so Dune Networks, acquired by Broadcom, RS Plus, which is shipping today, supports up to 6 label. Jericho, which is coming next year, is going to support between 7 to 13 labels. If you look at Juniper, they will probably today it's around 6 to 8 labels. They should have no issues doing 16. Same goes for NCS. So 9K, which runs on NP5 today, can do 8 labels. However, if you look at segment routing as such, it's a control plane concept. So there are very little cases where you try to pinpoint traffic across all the paths. So in most cases, you will be able to compress paths as part of loose. So if it's loose, you just need one label to reach a loopback of a node. If it's strict, you are going to pinpoint interfaces. Same way you do in RCPT. So after some analysis, there's 10 well-known topologies. We've seen that 90% of today's requirements can be met with up to 3 labels in the label stack, meaning you just need to upgrade software.
Окей. И все же, если говорить о data plane,
and if you talk about this, just answer the question: how much should I pay for one DNG port? If it's a Broadcom switch, it's $70 without optics. Thank you for the answer. I didn't know it. Well, I wouldn't say that the typical Tor switch is a transport device. If we talk about
As dual RPs, it's very different picture, very different price point. Or if you go with something which is off the shelf, Broadcom, it's really cheap. Probably if you go to Quanta website, you can get a switch for $5,000.
Здравствуйте, Александр Кравченко, Чайный Телеком.
Alexander Kravchenko, my question is, you showed the configuration for the American telecom operator, the big operator. Does your controller has any limitations or recommendations for the building on the broad scale nets? How do you solve the problem of the consistency and scale problem? Because if you say that you can, in real time, you can follow the BGP processes and react on them, respond on them from your controller. So how do you solve the issue of latency between the upper and lower level, and how it is synchronized with the protocols? That's a good question.
Operation. We are talking about control plane. The message exchange between nodes and controller is BGP based, so we are talking seconds. If you want to provision faster route, it still has to be instantiated in forwarding plane. So what you're going to do, you are going to provision your primary LSP, you are going to provision your backup LSP, and you are going to associate this in hardware, so when primary goes down, you switch over to up. This is the only way to reach 50 milliseconds. In terms of how do we make sure information we received its final state and it's coherent? BGP has means of verification. It employs a way to encode an LRI in such a way if it's incomplete, it's an erroneous one. After all the updates have sent, normal BGP implementation will send flag, which is end of RIP. So you know for sure you received all the information and it's consistent. By utilizing young models, and if you look at OpenDaylight, when we receive BGP update, we are not building in RIP. We are building YAML3 immediately. So proper data model and BGP is done properly in ODL. Make sure that information coherent. Next hops could be resolved, and if next hop happens to be on LSP, there's actually an LSP to the next hop. So obviously any implementation has bugs, but what we see today, it works pretty well. In terms of clustering, it's specifically about OpenDaylight. We integrated a data store called Akka. There are some testing ongoing. I know that standalone Akka can support up to 10 million transactions per second. So it's high performance data store. Спасибо большое за внимание. И опять-таки, если есть какие-то
Thank you for your attention. If you have any questions.